the clock is ticking. Okay. Yes, they've looked at this problem. Well, it tells you it's a tangent. There's no roots on it, so it can't be. Okay, but it's supposed to be something squared, not something to the fourth. Yeah. Okay, well, you need to let me talk. This one's got an extra step, and this is the mean part.
She's putting us down.
Okay? It also, to be an inverse tangent, it not only does it have to have an x squared up here, it has to be a 1. Not a 4, not a 9, not any other number. It's got to be a 1. So if you don't have the 1 in the right spot where you're supposed to, that's the first thing you have to do is make that become a 1. So this 4 right here has to become a 1. So how on earth can you make it become a 1? Yeah. Essentially what we're going to do is we're going to pull it out front, and actually I'm going to take the 3 with it while I'm at it. Might as well get it out of my way too. I don't want that 4 there. I am factoring it out in front. Now why am I putting it on the bottom? Because it came from the bottom of the fraction. So if I take the 4 out, that becomes a 1. But what happens over here on the 9x to the 4th? Yeah. It becomes 9/4 x to the 4th. Then you now have to do the second thing we did. Now you have to figure out, this has to become a u squared, where the 9/4 x to the 4th is. So what are you squaring to make 9/4 x to the 4th?
9/4 x squared.
What do you square to make 9/4?
3 halves.
3 halves x to the second. That's what you substitute.
Are you kidding me?
Yeah. So 3 halves x squared. I would have not have said it with that much emphasis if I was kidding.
You know how much work this is?
Oh, poor baby.
I'm not going to remember this on Monday.
So you now have turned this thing into 1 plus u squared. That's what you need. Now I got to get rid of the x. I can't have a mixture of variables. So how do I get rid of the x? Yes, I got to do the derivative of my substitution up here. So du is going to equal a nice little 3x. And then I'm going to divide it over to the other side. And yes, you'll notice that the 3's cancel as well as the x's. So sayonara to the 3's, goodbye to the x's. And so we are left with now a nice, clean little 1/4, 1 over 1 plus u squared. And is that our inverse trig function rule? It is indeed. So it becomes what? 1/4, that's inverse tangent of u. And then last but not least, I have to substitute my u back in, which I just moved. U was what? 3 halves x squared. Okay. So I would end up with 1/4 inverse tangent of u of 3 halves x squared. Let's see. So the key thing is you must make the 1 first, then do the u substitution. I have one more because this gets a touch trickier if it's in a root. Make it become a 1 verse. You got to make the 1 there. If there's a number, like we had a 4, you got to make the 1 appear first.
This like 3 steps are integrating a function which results in an inverse trig function.
Yeah. Okay. So what's my third? What was I thinking of when I said 3? Make the 1 first. I guess, yeah.
So step 3 solve.
I guess. Solve and put substitution back in. All right, our last problem, sad but true. I know you all hate to quit. So I have planned something exceptionally wonderful for you. Actually, I'm drawing it inside. I think I just want to put that on another slide. We have plenty of room. No crowding. How am I doing on time? Oh, we're good. Okay. Oh, look how fun it is. It's trig functions. The integration signs? Integration signs are fun. Trust me, after you make them for the next 3 months or so, you'll be really good at making them.
Yay! Well, it's different if I didn't have my line.
They can't go.
Look at mine.
All right, according to the set of steps I just gave, well, actually, first of all, what tells you this is even an inverse trig function? Down to square root? Which inverse trig function do you think it might be? Okay, Quinn says a secant.
Because the square is towards the front.
The square term is up front, yes. That's a big hint.
Good observation.
So should I immediately sub out the sign? Make it a u squared?
I say we can take the sign out.
I got to make 36 become a 1.
You gotta take.
Now how do I do that when it's inside a root?
You're gonna pull out a.
I have to pull the 36 out. Okay? But then when I pull it out, I actually have to take it completely out of the root. So if I take it out of the square root, the 36 will become a what?
6.
It becomes a 6.
4, 6.
So yes, you will have 4 6 out there because you're pulling the 36 out, which becomes a 6 when you square root it. Leave the cosine sitting there for a moment. We hope it cancels. So I now have a sine of x. What do I have on the inside if I have pulled out a 36? Sine squared. Something else. If you pull 36 out, you got to divide both terms by 36. So this is sine squared over 36. No, not when there's a minus or a plus in there. You can't do individual terms. So now, once you make the 1, then you start looking for what are you going to u substitute. So what is it we need to become u? We need the roots to be u squared minus 1. So therefore, you have to ask yourself, what am I squaring? If that's got to become u squared. I would be squaring a sine over 6. So therefore, you are substituting sine over 6, or, since I think that may cause you issues, realize that's 1/6 sine. It's easier to do the derivative if you think of it as 1/6 sine that you're substituting. So the derivative will become 1/6 cosine. That's no big deal. When I move it to the other side, the 6 will end up where? The 6 will end up on top, so we'll end up with 6 over cosine times du.
Whoa! We're making fun of my bad handwriting. That's not acceptable. I don't realize that by now, guys.
So I'm subbing in dx.
Yeah.
Yeah, I have left gaps because I want you to debate. Should I put the cosine on top? Why? So it cancels. So yes, you would definitely want the cosine to go on top so we can ditch those babies. Okay, what about this sine out front? Do I need it out there? Can I have that sine out there? I couldn't have that sine out there. What inverse trig function did you tell me you thought this was? You told me you thought this is secant. Secant has to have a variable in front. So if this is u squared, that needs to be a u out in front of it. So let's gotta go one more here. So that sine of x, I need to come up here and solve my substitution, my original substitution here. I need to solve it. I need to replace sine of x. So if I solve for sine of x, it'll become what? 6u. So you are putting a 6u in place of that. And the 4/6 I'm reducing to 2/3. And then, yeah, look, the 6's cancel. Sayonara. Another one.
I feel like I was playing this far.
Never. These are never rigged. It's all magic. So I'm going to clean it up so you can see it then. You now have a 1 on top, a u on the bottom, times a square root of u squared minus 1. Is that the correct inverse trig function? Yes, that is inverse secant. So therefore, when I integrate, it becomes 2/3 inverse secant of u. And then you just need to put your substitution back in. 4/6 became 2/3. So 2/3 inverse secant of 1/6 sine of x, or they might write sine of x over 6. Either way is okay. Let's see. Now, how much fun is that?
Not fun at all.
All right. So, Jesse, hope to see you next week.